Hi everyone, and welcome to our talk on Kedro. And why should you use, or why should you consider start using Kedro for building production-ready data science pipelines? My name is Ionut Barbu. I'm leading the data science team at Bright Cape. Bright Cape is we are a data solution consultancy based in Eindhoven, and we also do a lot of work in data engineering, data analytics, process mining, and today you'll be also, besides introducing some concepts about Kedro, we'll also walk you through a concrete use case we did on leveraging Kedro for one of our clients, where I work together with Tim. So maybe also.
Well, my name is Tim Brakenhoff, and I'm a data scientist at Bright Cape, and well, we work together on a project for Eike, which I will tell more about later.
All right, cool. So quick expectation management of today. So we're going to set the stage. So why did we choose to go for Kedro in building our data science pipeline? So a bit of a rationale about the motivation behind actually developing Kedro and about using Kedro in our project. And then I'll be focusing mainly on the concept, on the walk you through the 4 pillars, the philosophy behind Kedro, and then Tim will dive deeper into the practical use case, the project we did for one of our clients. But before diving into the content, I'd like to ask a question to the audience. So what percentage you think of advanced analytics projects never make it to production? Any thoughts? Any guesstimates? 90%. Actually, I heard 90, which is very, very close to this based on this reference. So based to this article we found, and actually was referenced in multiple places on the internet, it seems that around 87%, 90% of advanced analytics projects never make it to production. And there are many reasons for that. Obviously, maybe the business question was not asked right from very start. So people maybe just wanted some proof of concept, some extracting some insights, and never really had this vision of building a project, delivering a product. Maybe they did have that, but they didn't start in the right way. And sometimes just the data was just too crap. The data quality was not good enough, and then it didn't worth bringing to production. But besides the data issue, and besides asking the right questions, I think in the end it's really about taking a step back in the beginning. And what are you trying to build? Are you trying to build like a Jupyter notebook or a simple pipeline just to extract one-off insights, doing one-off analysis, or are you trying to build a product? Are you trying to build something that is going to be frequently rerun in production, which is maintainable, reproducible, and also modular? And in order to get to the second state of having this massive product which is reliable and maintainable, there are many challenges that we have been facing, and maybe some of you might relate to this. There are so many tools out there. Even today, by attending the presentations, like there is again a new package, Polars, with Onyx. There's so much out there, so I think it's difficult to see the forest through between the trees. If for the Dutch people might relate to that, a bad translation. Also, another challenge is joining a project which has been going on for a while and trying to understand the code base of someone else. If there's not enough structure, no standardization, and many other challenges. I'm not walk you through all of them. And I think maybe this one was worth mentioning. I've seen also today, and I think many of you don't have a software engineering or computer science background, maybe just have a science background, as I have physics. So my software engineering best practices or skills are far from ideal. And this was also one of the motivations behind Kedro, like how can we embed software engineering best practices into a tool, into a framework, so that data scientists can get up to speed on doing a project without thinking of all the tiny gritty software engineering details. So let's talk about Kedro. What is Kedro? It's open source Python framework. It's developed by Quantum Black. They're based in London. And it provides a framework for building reproducible, maintainable, modular, data science code and data engineering, data processing code. And there are a couple of, say, advantages of using that from our experiences. I mentioned already the software engineering best practices that are embedded in it. Also helps, thanks to the design choices, to create a structure and high quality code. And very useful is this handover from development phase to production phase. And this is where Tim is going to tell you more about that, how we did it for our client. And there are four concepts, for main characteristics of Kedro. So it's the project template. It's inspired from the Cookiecutter Data Science, maybe familiar with you. So this gives you this predefined built-in structure of your data science project, so you don't have to think about that anymore. Configuration, this is where you can hard code the parameters of how to manage your data, how to manage the interface between data in your code. The data catalog, this is a plain YAML file where you can store your data set or any database connectors when you move your code into production. And then everything is built into nodes, which are nothing more than a Python function with an input and output. And if you stitch together multiple nodes, you get a pipeline, what is often fancy called as a directed acyclic graph DAG. In a project template, really the idea is to have this predefined structure, and you see here what you get when you create from scratch a new Kedro project, Kedro new, and then you get this template, this predefined folder structure. So you have already the predefined places where you can store your configuration, where you could do some exploratory data analysis with notebooks, where you can define your source code in the Python script, and also you already get already predefined built-in places to build your unit testing, should you go for that. Another nice thing about Kedro is the integration with Sphinx and also with Pytest. So if you, for example, if you decide to use Sphinx for documenting your code base, and if you did a nice job in documenting your functions with doc strings and also provide the right structure, then when you build your documentation, the Kedro takes care of stitching that everything into one place and then creating a nice HTML-based documentation. Probably familiar for you. Now, what about the configuration? Again, this is the place where to store the requirements for the logging, for integration. For example, suppose that you build a data science pipeline for to be machine learning or predictive modeling part to that. This is where you can store the hyperparameters of your machine learning model. So you don't have to put that in code. You put them in a separate configuration YAML files. So in order to have this separation between the data layer, the configuration layer, and the code layer. And there also another advantage of configuration is that you can keep your credentials for accessing, for example, cloud storage, again, outside of your code base. So when you package and you deploy and you share your Kedro-based project, your credentials are automatically not included. So you don't have to think of that. They're just left out of a packaging step. Then, what about dataset support? There is a bunch of data built-in data support. So like the major Python packages and the data sets are supported. Think of CSV, Excel data sets, Parquet files, Feather, Spark are supported. And also there is support for having your data on in the cloud. Personally, I've been using the Azure cloud. Yeah, it's there still. And there is also the nice thing about this growing community around Kedro is that if you don't have a connector for your data set, for example, we did a project with using KNME data, then we didn't find a predefined connector from Kedro, and then we built our own custom data set, and then we're going to publish that to their repository. So we talked about the project template, we talked about the configuration, we talked about the catalog, what else? We have nodes and pipelines. So here, again, node is nothing more than taking a Python function and wrapping that with an input data set and output data set. When you have multiple nodes stitched together, you get the pipeline. You get this directed acyclic graph. And yeah, you can imagine if you have a large project and you want to build it end-to-end from data ingestion, do some data cleaning, data pre-processing, feature engineering, modeling, and maybe also some inference. Things can get pretty hairy, pretty out of hand. So it's good to have to keep an overview. Hey, is the data flowing the right way from start to end? So the developers of Kedro thought of that, and they developed Kedro this. So what you see here is a visual representation of the pipeline we have built in one of our projects. So here on the top we have the input data set, these nice small what are they? Squares. They are the pipelines. And then you see here how the data is stitched together into the data engineering pipeline. These are the outputs. Then they're brought together into the data pre-processing, I think. And then you have here the modeling, some exploratory, and finally the reporting pipeline. And this is an interactive web-based tool, this Kedro Viz. So for example, you can expand the pipeline and you see this like being blown up, and you see all the individual nodes that made up the pipeline. I can also, for example, if you want to select the modeling pipeline, then this is going to be blown up and then zoomed on, so you can just do some analysis. And if you are way too much, you can deselect the data sets, and then you can focus on the functions, on the nodes. And you can also switch to white mode if you prefer that one. And there's much more to this than what we show on this video. You can also like see the code behind it. I think what it misses, and we are in touch with the developer, is really being able to execute it from this interface. So this is purely as a communication tool. It's also useful from our experience to take the client along, especially in the first weeks when you're building the data engineering pipeline. There's not so much insight probably coming from your work, and then the client is asking, hey, what am I spending my money on? And then it's good to show them the progress by just, hey, we started with these 2-3 nodes, and now 1 week later we have a pipeline, and then in the end you start creating some nice insights from your data. Any questions so far before I hand it over to Tim? Yes.
Thank you very much. Regarding the additional data that you get after the model is trained, can this also be added in your pipeline?
Yeah, indeed. So this is
train the model from the beginning.
Huh?
You just need to repeat the question.
Yeah. So the question is, maybe if I go back here, can I go back? Yeah. So the question is, okay, we start with our raw data set, and then we do some processes, and you get some new intermediate data sets. It's also definitely possible to store that also in the data catalog. And this is actually what we see here. These are the raw input data sets, and these are some intermediate process data sets. And I think some of these data sets are the actual trained machine learning models that you can eventually deploy, for example, to Azure or Amazon.
So you don't have to retrain the model. You just get the additional data and you train that on the new data, or you have to repeat all this process from if you get the new data?
If you get new data and you want to retrain, you have to rerun the pipeline, obviously. Yeah. But the model will be stored somewhere in a dedicated folder. So your inference pipeline can just pick the model, the pickle file that contains the model, and use it for inference.
Thanks.
If no more questions, then
Clicker. That will be handy, right? Well, thank you, Ionut. Then I will tell a bit more about our use case at Verijken. So, who's Verijken? Verijken is a large Dutch agriculture player in the southeast of the Netherlands, and they produce tomatoes. To provide light to their tomatoes, they can pick between 2 options. They can either directly consume it from the grid, or they can produce their own. And they produce their own by gas-powered cogeneration units. Why use gas-powered cogeneration units? Well, due to their high efficiency. So it produces electricity, heat, and CO2. And normally, heat and CO2 are waste products, but of course, in a greenhouse, you can actually use those. The second reason is that gas, until recently, was relatively inexpensive. However, we all faced it, the gas prices kind of exploded. And that made the, no-brainer option to pick the code generation units was now becoming quite expensive. So Vereike thought by itself, can we reduce our costs by making more effective use of our resources? And that's where Ionut and I came into play. So they asked us to write an optimization model for them. Together, we decided that we would split it in two phases. So first a development stage and then a production phase. The development stage was a proof of concept, so we were actually going to show whether there was a big enough benefit for them by using the optimized schedule. So is it actually worthwhile to do the project? And if that's the case, then integrate it into our production systems. Well, we were first running our development stage on our local laptop, and we were using just a snapshot of data, so an Excel data dump. After that, we would integrate it into their systems, and we would run it on a virtual machine, and we would hook it up to a SQL database which contained live data. So, what after development, how did our pipeline look like? Well, Kedro is a modular package, and we split our pipeline into three modules. So the pre-optimize to ingest our data and wrangle the data and make it ready for the optimization unit. There we calculate the optimized schedule, and then after that we calculate all of the potential cost reduction in our post-optimize, and then we output everything to an Excel so we can visualize it to Vereike. What already strikes is that optimize is a relatively small component of this whole model, and I want to stress that this is not necessarily where we are using Kedro for. We are using Kedro to have the whole orchestration of this pipeline, so for the pre-optimize. When does what function run? What is inputted to those functions? Where are my data sets stored? What parameters am I using? Yes, and then coming back to your question, these modules can each run independently of each other. So you have intermediate data sets, and with those intermediate data sets you can run a certain module, which is really handy during developing, because otherwise indeed you have to run everything again. So we already said we were first using a data dump, and now we are going to use a SQL database. So just short back, development stage was actually successful, so now we are going to the production state. So, switching to the SQL database, what actually changes? Well, the pipeline itself, if the format of the data remains the same, then nothing changes for the pipeline itself. So where we need to make our changes is actually in our settings or configuration, or more specifically in our data catalog. On the right you can see for the development stage we had a Excel data set, and for the production we are using a SQL data set. And of course what comes with the SQL database is that you also have to specify with which credentials you are connecting to that data set, to that SQL database, which you can see over here. Oh, we go back. Then we had our option for deployment. Well, Kedro comes with several deployment options. We actually could run it on a single machine, so we picked the single machine deployment. However, Kedro does come with a lot of distributed deployment guidelines, and you can see that there are many platforms which you can integrate to Kedro. So for us, the single machine deployment, we had three options. Copy our source code, create a Python package, or create a Docker image. Well, the source code, or completely copy your source code, is a complete version. It's really easy to share. However, it has a really limited code security. So the client could accidentally make changes to the code, which we don't want. So we didn't want to pick that option. Then the Python package, it's really easy to create with Kedro, it's easy to install, and it's also really easy to configure. Another option was the Docker image. It has the best security of them all, and it has no software dependencies. However, it can be a bit more difficult to set up, and especially if Eike didn't have any knowledge of Docker images being run, so therefore, and also they also already had a Python server running, so we picked the second option. And what did that actually look like? What did we do? We shared our code through a GitHub repository where we had our Python package which we created, and that Python package contained all of the source code of our pipeline. If in the future we would want to create a new version or do an update, they would simply only have to install that new file, and they cannot really change anything to the code, so a better code security. We also provided them for the first time with a configuration, so how do we run the pipeline for the first time with which parameters, and after that they can change it themselves. And we provided them with documentation about the model itself and how to install everything. On the right you can actually see what it looked like. So we had a virtual machine running with our Kedro package installed, which contained our pipeline. And on that virtual machine you have your own configuration as well. And in that configuration it also says where to get your data from, so in this case the SQL database, and also how to connect to that data. However, of course, what we already mentioned, those credentials you don't want to share on a GitHub repository, so the first time you're setting it up, you have to set that up yourself. And also, things that we don't want to share is logs, so that's specific to each machine that's running the code. And then afterwards, Eike decided that they wanted to create a dashboard on the output we delivered to the SQL database. So they were creating a, they visualized what their current decisions were, so their schedule, and also what our optimized module said they should be doing, and then calculate what the potential benefit could be. We actually already did that, but they visualized it. So what did we finally deliver? We successfully delivered a Kedro project, and we integrated it into their production systems. With the use of their own dashboard, they could also look into their past decisions and see what they could do better in the future, so actually make those cost reductions. And the estimated cost reduction was projected at 10 to 15%. And well, Kedro provided us with a lot of tools and a lot of structure, and that we had an overview of the pipeline, that we could visualize it. But I also want to stress that the next person that is going to use it also has those that structure. So if a colleague of mine would start a third phase, he could quickly get up to speed. We have the documentation, he has a template where he is familiar with, and that's really valuable. And I think that's it. Any questions?
Kedro gives a lot of structure for you as a team about the pipeline. Do you think that also the client, for Eike in this case, sees the value of that, or they just want to see the output and you don't give them insights into the pipeline basically? So do they see the
added value?
Or is it more for the team itself?
Does the client also see the added value of using Kedro? And that's not only for us giving the structure. Yeah, I think it's really handy for us that giving the structure. Also, if they would go to another consultancy company, then they could also get onboarded with our code without us actually telling what is happening. They could quickly install it, all of the requirements are there. And also what is really handy is that you can visualize with the Kedro visualization. So you can say, we are calculating these data sets for these and these reasons. So that's a bit of added value, I think.
And I think I can add too. I think it depends very much on the client. Like Verizon was quite, if you think of an analytics maturity curve, a data maturity curve, they were very low. They were like in the left bottom corner. On the other hand, now we have been working with another client who was a bit further away, and we before we delivered the project to them, we involved a Python developer. So we took him along again, just to walk him through the code, and he appreciated a lot the structure and the organization of a project. So if you speak mainly to the business, probably they will appreciate the added benefits of Kedro much less than a data scientist or a data engineer at the client who's going to work with the code and hopefully continue to improve it.
Have you used any other framework before that? Is it the first time you use a software framework for data science?
I mean, like to really stitch together everything. I think just a little bit Cookiecutter Data Science, and as I said before, the project template is based upon that, but it missed all the other integration that Kedro now provides. So I think besides Cookiecutter Data Science, I didn't use anything else. Yeah, please.
Maybe my question is also related to the previous one. I'm wondering why you directly went to the Kedro, or you experimented other type of Python packages with the same goal, and you find out that this one is more beneficial for your case.
Yeah, so the question is again, why did we choose Kedro for orchestrating and building our managing our projects. And it's not only about creating the pipeline, but how to manage and structure our project. Is this question? Why did we choose Kedro?
Yeah, and what about other options? Maybe there are other options you experimented those ones and compared and went to this one and then because of the benefit is better than the other, or it is the only option now that you?
I think there are indeed some other options out there. I have been using Kedro. So before joining Brightcape, actually I was working at Quantum Black. So this is where I started to use it because we developed Kedro, so I started using that. And I think 1 or 2 years ago, Kedro is now part of the Linux Foundation, so it's now open source, so everyone can use it. And I think they did do a competitive landscape, and there are indeed some other similar packages, and each has pros and cons. And I think overall, Kedro at this moment at least still provides most benefit compared to the other frameworks. So personally, I just used. I was very familiar with Kedro. I did see the benefits, and then we're using that at this moment.
What was the time frame that it took for you to build this whole, let's say, pipeline? And also, the second question on that, like, if you wanted the first option, so instead of doing like the manual configuration and all that, if you wanted the first option, how would that look in a manner of time and cost?
First option of what?
You said like you had the option to go with Kedro, like integrate with AWS, etc., etc. But you went with the second option, with the bottom option, to do in a way like a more manual.
He talks about that deployment option.
Yeah, that's the single machine deployment.
I didn't really fully explore the distributed deployment because we had a relatively simple model that could run on a single machine.
Yeah, and I think we are constrained by the IT environment of a client. So the client, I think for at least two reasons. One, on the other hand, the client had this Python server, and so we already had this predefined IT infrastructure that they gave to us. Hey, put your code, put your model out there. This is one thing, and I think from a performance perspective, the pipeline is not that heavy on resources. I think end to end, I think less than half an hour to run it, and of course you can adjust. Of course, it's a linear optimization model we built, and you can have to run for 30 minutes or for 3 days. And I think I think in the end we went for something that runs around 30 minutes. So this is why we chose Does this answer your question? Why we chose for this route?
Yeah. And the first question was like, in what time frame was
Yeah.
this whole pipeline built? How much did it take you? What time?
How long was that? I think the first phase was like 3 months or 3.5 months. And I think that's really
Yeah.
good for us. The moving to production was like really
But
much more
yeah.
shorter.
And I think with 3 months we didn't work full time on the project. Maybe I don't know 60%.
Yeah.
Yeah, like 0.6 FTE. One more question? Maybe you, sir.
Maybe one thing that popped up into my head that I didn't really catch here is how does it help you version ML models in it? Like,
Tr-
you
very good,
do
yeah.
experimentation, presumably you have lots of models before you arrive on a final one. How
Yeah.
does that kind of workflow look like? Because for us, for example, doing experiments in lots of these managed solutions is really quite difficult. And if you stick to something like Airflow, there it's hell because if you
I see.
restructure a pipeline, you delete the history
I see.
basically. Yeah. So how does this look like?
So Kedro has a plugin. Oh, so the question is again, how does it integrate, or how do you manage machine learning model? How do you do versioning on machine learning models? And is there any integration with MLflow? And yeah, there is a plugin for MLflow. And I think the video that I showed in the beginning, that bigger pipeline, that one we had integration with MLflow. We did contact regression, and then we were able with MLflow to monitor the versioning. And that's possible because one of the data sets that is supported by Kedro is an MLflow artifact data set. So on the one hand, that also stores on this, but also pushes automatically to the MLflow framework.
So it pushes to it and then reads back from it.
Yes. Yeah. So it's fully integrated with MLflow.